Today, cars are no longer just mechanical systems. They are complex systems driven by electronics and software. Functions like steering, braking, or advanced driver assistance systems are now controlled by code. And this introduces a new type of risk, because a simple software bug can potentially lead to a catastrophic failure. That's exactly why functional safety has become critical in the automotive industry. So, what problem does ISO 26262 actually solve? Over the past decades, vehicle systems have become increasingly complex. More ECUs, more sensors, more interactions between systems. Without a structured approach, it becomes impossible to guarantee safety. Different teams might work in silos, risks might be underestimated, and critical safety activities might be missed. ISO 26262 was created to bring structure, consistency, and rigor to the development of safe automotive systems. So, what is ISO 26262? It is an international standard dedicated to functional safety for electrical and electronic systems in road vehicles. It is actually derived from IEC 61508, but adapted specifically to the automotive context. Its goal is simple: to ensure that safety is systematically engineered throughout the life cycle of a vehicle system. At its core, ISO 26262 is based on a very simple idea: identify hazards, assess the associated risks, and reduce those risks to an acceptable level. To achieve this, ISO 26262 defines a complete safety life cycle, often represented as a V model. This life cycle starts at the concept phase, continues through system, hardware, and software development, and extends all the way to production and operation. The key idea here is that safety is not something you add at the end. It is something you build from the very beginning. And everything starts with the concept phase. This is where the system is defined and where safety begins. At this stage, we describe the item, meaning the system under analysis. We identify potential hazards, and we define high-level safety goals. This phase is absolutely critical because it sets the foundation for everything that follows. One of the most important activities in this phase is called Hazard Analysis and Risk Assessment, or HARA. The objective of HARA is to identify hazardous events and evaluate how critical they are. To do this, we assess three parameters: severity, how serious the potential harm is; exposure, how often the situation can occur; controllability, whether the driver can avoid the harm. So essentially, we think of what can go wrong and how bad could it be. Based on this analysis, we determine something called ASIL, Automotive Safety Integrity Level. ASIL ranges from A to D, with D being the most critical level. The ASIL defines how rigorous the development process must be. The higher the risk, the stricter the safety requirements.
Once the ASIL is defined, we move from risk assessment to defining safety requirements. Each hazardous event leads to what we call a safety goal. A safety goal is a high-level requirement that aims to prevent or mitigate the hazard. For example, imagine a situation where the vehicle accelerates without driver input. The safety goal would be to detect this situation and limit the acceleration to a safe level. These safety goals are then refined into functional safety requirements and later to technical safety requirements. And this is where engineering really starts. The system is developed across three main levels: system level, hardware level, and software level. At each level, the safety requirements are broken down and implemented. At the system level, we define the overall architecture, the technical safety requirements, and how different components interact. At the hardware level, we design safe electronic components. And at the software level, we implement logic to detect faults and control the system safely. But defining and implementing requirements is not enough. We also need to ensure that everything works as expected. This is where verification and validation come into play. Verification answers the question, did we build the system correctly? while validation answers, did we build the right system? To do this, engineers perform tests, reviews, and safety analyses throughout the entire development process. And one key idea in ISO 26262 is that safety is ensured step by step. Each level verifies the previous one. Each requirement is traced from the initial hazard all the way to implementation and testing. In other words, ISO 26262 ensures that safety is not left to chance, but is systematically engineered throughout the entire life cycle. Thank you for watching this video, and see you soon.